All right, so today we are going to start our new chapter, chapter 4. We are going to graph quadratic functions today. If you remember, a quadratic function is a function that can be written in the form of y equals ax squared plus bx plus c, where a cannot equal 0. So you need to have that x squared term in there. And then remember how it graphs out here. You got a graph there of a parabola. So we're going to be looking at some of those today. So some orientations of the parabolas, if it opens upward, A is positive. So in the example down here, you've got your A value there is 2x squared, because remember it goes y equals ax squared plus bx plus c. So my 2 there is my A value, and it's in front of the x squared. Since that is positive, it's going to open up, and you're going to have the vertex down here is going to be the minimum value. It's going to be at the bottom of the graph. And then when A here opens down, the vertex is the maximum, and look at your A value this time, it's negative. It's a negative 2. So it says A is negative, therefore it's going to open downward. So we have a line of symmetry there. The formula for the line of symmetry is x equals negative b over 2a. So you're going to have a vertical line, and it's going to form on your graph there. So we're going to look at these. We're going to use the function y equals negative 3x squared plus 2x plus 1. And answer these questions here. It says, tell whether the graph opens up or down. Well, if I write y equals ax squared plus bx plus c. Look at your a value here, it's negative, so your graph there is going to open down since a is negative. Um, it says over here, it says find the equation for the line of symmetry. Well, we've got a nice formula for that. It's x equals the opposite of b all over 2a. And our b value up there is 2. So I can plug that in there. So negative 2 all over 2 times my negative 3. So I can clean this up. Negative 2 all over negative 6, which gives me 1/3. So x there equals 1/3. And now we can graph that out if we wanted to, because that's what letter E there tells us to go ahead and graph it. So um, I'm going to go ahead and put that down on here. So 1/3 is about right here, kind of. So it's a vertical line there at 1/3. And then it says identify the max and the min. Well, since this is 1/3 for your line of symmetry, your maximum is also, the x value is 1/3. And then what you want to do is you want to plug it back into the formula up there. So up here at the top, you're going to plug it back in there. So y equals negative 3 times 1/3 squared plus 2 times 1/3, and then plus 1. So we can just go ahead and put that directly into our graphing calculator there. So, and when you just plug the values in there, go negative 3 parenthesis 1 divided by 3 parenthesis squared plus 2 parenthesis 1 divided by 3 n parenthesis plus 1. And when we end up doing that, we end up getting 4/3, or 1.3333, however you want to do that. So if we want to write it as a decimal, we'd say 0.3 repeating. This is 1.3 repeating if you'd prefer writing it out like that. So now I can graph that 0.3 and then up 1.3. Looks like it'll be right there a little bit. And then it says find the coordinates of the vertex there. The coordinates of the vertex there, we found those already. It's 0.3 repeating, 1.3 repeating. And what they really want to do says identify the min-max value there. The min-max value is actually your y value of your vertex, so it's actually looking for this value or this. So we graph that, and now if we want, we can go ahead and find another point here. Something kind of nice here. Your C value here is actually your y-intercept, which in our case here is 1. So my y-intercept here is 1. And we said this is going to open down. So you can use symmetry here. Since it's 1/3 and then 1 down here, I can go 1/3 over here and go 1 down over here. And I can connect those. I won't always do them like that one. That one just seemed easy in this case. But there's one way of being able to graph it. Again, kind of to show you, see there is 1, so I went, my y-intercept there ends up being 1, and since I was 1/3 from the from the line of symmetry over to 1, I can go to the right the same way. I go 1/3 over, which puts me at 2/3, and then I'm still 1 up, so the ordered pair there'd be 2/3 and then 1 up. So let's graph another one up here. So this one here, again, if I put y equals ax squared plus bx plus c in here, my a value is what's in front of my x squared there, which is -1. So since a is negative, it opens down. Find the equation for the line of symmetry. We can do that opposite of b all over 2a. My b value up there is -1. And all over 2 times -1. Well, the opposite of -1 there is just 1, and then 2 times -1 here is -2, so I get -1/2. So to identify the min or max value there, we can go ahead and take -1/2 and plug it back into the equation up there. So I can go y equals opposite -1/2 squared minus -1/2 plus 5. And again, I can just go ahead and put that directly into my calculator there. I can just go negative and then in parentheses -1 divided by 2 n parentheses squared minus parentheses -1/2 n parentheses plus 5. And when I end up doing that, I get 5 1/4, or if you're a decimal person, you would say 5.25. So this is what they're looking for. And then if you remember, I can go back to your, it's opening down, and we said when it opens down here, you have a maximum. I don't think I did that on the other one here either. This had a maximum as well. So the one we're on here has a max of 5.25. So now let's go ahead and write the coordinates of the vertex here. The coordinates of the vertex, you take your line of symmetry value, and you take your min-max value here, and that actually ends up giving us our coordinates for our vertex. So now I can graph this out. I'm going to put my line of symmetry in here. It says it's sitting there at -1/2, just a vertical line there. And then I'm going to graph the ordered pairs there in letter D there. The vertex there always sits here on this line of symmetry someplace, so it's -1/2 and then up 5.25. So 1, 2, 3, 5, and then a quarter there. That's not very good, but it worked. So we said it's opening downward. So from that point now, it needs to open downward. So kind of looking back over here at our generic version here. This one here is the one that opens downward, so it's got to look something like that. So we need some other values here to find that. So let's go ahead and figure that out. Again, we could use our C value. Our C value in this problem here is our y-intercept. And our C value here is 5. So on my y-axis here, 1, 2, 3, 4, 5. And this can get a little tricky here. There's a half in here, and then we're over here at 5, so there's got to be a half in here and down here at 5. And then we can connect those. So it's kind of nice to be able to use your y-intercept to graph that out. So we got another one here. We got y equals -3x squared plus 5x plus 10. And again, we have to figure out if it opens up or down, and it looks like all of ours have been opening downward this time. That's all right. So y equals ax squared plus bx plus c. So our a value is what's in front of the x squared there, which is -3. It's negative, so it's going to be opened down. Find our line of symmetry. We always use opposite of b, all over 2a. Our b is what's in front of the x there, which is 5. And then our a value is -3, so I can clean that up. -5 over -6, which gives me 5, 6. I'm going to leave that exact for now, and then I'll change it later into a decimal. But for now, I'm going to leave it as a fraction there. So now let's go ahead and let's look at, let's plug in a positive 5, 6 into our equation. So y equals -3 times 5, 6 squared plus 5 times 5, 6, and then plus 10. So again, to go ahead and clean this up and solve this, in my calculator here, I'm going to take -3 parenthesis 5 divided by 6 n parenthesis squared plus 5 times parenthesis 5 divided by 6 n parenthesis and then plus 10. If I want to write that as a decimal, it'd be about 12.083, and then the 3's there repeat. So I could do that, or if I can get it to change into a fraction there, that works too. So I could also have it as 145 over 12. So it says find the coordinates of the vertex there. It's letter B there, which is 5, 6, and letter C there, which is 145 over 12. And remember, this again is a maximum because it's opening up, it's opening downward. So this is the top point, so the top there is max. So now we can graph that out. 5 divided by 6 there ends up giving me, if I want to put this out, 0.83 repeating. So I'm going to come over here, 0.83 here, and that's going to end up being my line of symmetry. So really close to the one line here. And I'm going to plot 5, 6. And then I got to go up about 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I want, I can keep going with my lines here. 11, 12. So 12.08, which would be about right there. And then my other one there, I can go ahead and graph my y-intercept. So y-intercept there is at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then since I'm 0.83 this way, I gotta go 0.83 this way and up here to 12.08. And nope, did that wrong. Let's erase that. Let's go the correct direction. This one here was at, there we go, 12.08. So symmetry is this way here. This one here is 0.08, 0.08. So I got to go over here a little bit, 0.08. There we go. Now we're opening downward, and there's our vertex. So we graphed out another one there. So I want you to go ahead now and you get some practice with those. I hope that helped with graphing. So there you are.